Now imagine a teaspoon of sugar. Now imagine that teaspoon of sugar weighing as much as a mountain. That's astonishing reality of neutron star. The density of these celestial objects is almost unfathomable. Picture a mountain, a colossal hunk of rock and earth condensed into simple teaspoon. That's the kind of density we are talking about. Now, neutron stars are super dense remnant of massive stars that had exploded as supernova. These stars, once so large and powerful, collapse under their own gravity and explode, leaving behind a core of neutron-rich material. Now, this material is so dense that single teaspoon would weigh billions of tons here on Earth. These facts are mind-boggling, aren't they? Now, it's hard to wrap our head around such extreme densities, but that's the essence of neutron stars. They challenge our understanding of the universe and its limits. They remind us of the immense power of the nature and fascinating mysteries that it holds. So, how did we come to discover these astounding celestial objects? Let's delve into the history. The discovery of neutron stars is a tale of scientific curiosity and brilliance. It's a journey that begins in mid-20th century with an extraordinary woman named Jocelyn Bell Burnell, a graduate student in astronomy. Burnell was working on construction of radio telescope when she noticed something unusual, a mysterious regular signal. Now these signals, which were initially chalked up as interference from man-made sources, turned out to be something more significant. They were in fact radio emissions from celestial objects in the far reaches of space. Not just any celestial object, but new class of stars, neutron stars. These stars, unlike anything we knew before, were found to be spinning incredibly fast, with their rotation causing the radio signals to pulse. Hence, newly discovered celestial bodies were aptly named pulsars. It was a monumental discovery that not only confirmed existence of neutron stars but also opened up a new way of studying the universe. Now it's fascinating to think that these stars, remnant of massive stars that had exploded as supernova, were hiding in plain sight, waiting for us to unblock their secrets. And what secrets they hold? Composed of super dense, neutron-rich material. They possess intense gravitational and magnetic field and can range from 1.4 to 2.9 times the mass of our Sun. Now these stars play a crucial role in the cosmos. They are involved in creation of heavy elements and associated with phenomena like fast radio burst and soft gamma repeaters. As they age, they cool down, becoming cold remnants of the universe, their story etched into their layers, waiting to be deciphered. Now, with their discovery, a new chapter of our understanding of the universe was opened, a chapter that continues to engross and surprise us with every turn of the page. The birth of neutron star is a violent and spectacular event. This event is simply not the birth of any celestial object, but dramatic transformation of a dying star. Imagine a massive star, once much larger than our Sun, nearing the end of its cycle. Over millions of years, this star has been burning through its fuel, undergoing nuclear fusion that produces light and heat. But now it's running out of fuel. As this happens, the star begins to collapse under its own gravitational pull. This collapse increases the pressure and temperature at its core, triggering violent explosion that is known as supernova. During supernova, outer layers of the star are blasted out in the space, leaving the core exposed. But this is not the end. Instead, it's a beginning of something new. A core, incredibly dense, continues to collapse. The gravity is so intense that protons and neutrons are squeezed together, forming neutrons. This process gives rise to neutron star. This newborn star is a strange and fascinating object. It is incredibly dense. Just a teaspoon of this material would weigh billions of tons on Earth. It has also a powerful magnetic field and rotates rapidly, sending out beams of radio waves. If these beams sweep past Earth, we'll see neutron stars as pulsars, a lighthouse in the cosmos. But the birth of neutron star doesn't just create new celestial object. It also triggers creation of heavy elements. As the star explodes, it spews out clouds of gas and dust enriched with elements like gold and platinum. This material can later form new stars and planets, spreading the building blocks of life throughout the universe. The birth of neutron star, therefore, is a testament to incredible forces at work in the universe. It's a dramatic reminder of the cycle of life and death that governs not only our lives here on Earth, but also the lives of the stars in the heavens. So what are the peculiarities of neutron stars? Neutron stars as we have seen, are not your average celestial bodies. They're like the enigmatic cousins of our cosmic families, playing by the rules that seems bizarre and fascinating to us. Some of the most striking peculiarities of neutron stars is their intense gravitational fields. Imagine a gravitational pull so strong that a sugar cube sized chunk of neutron star would weigh as much as mountain on Earth. Yes, you heard it right, a mountain. Complementing this mind-boggling gravity is their equally impressive magnetic field. This magnetic field is like trillion times stronger than what this magnetic field is trillion times stronger than what we experience here on Earth. This is not ordinary magnetism. It's a force that can tear atoms apart, a force that's at the heart of some of the most extreme conditions in the universe. But the peculiarities of neutron stars don't end with their gravity and magnetism. These celestial objects are also renowned for their dizzying rotation. As the remnants of massive star, neutron stars retain the angular momentum of their predecessors, causing them to spin at an astonishing speeds. Some neutron stars, known as pulsars, can complete a rotation in a fraction of a second. That's faster than the blades of a helicopter. This rapid rotation, coupled with strong magnetic field, leads to emission of beams of radio waves. As the star spins, these beams sweep across cosmos like beacon of lighthouse. To an observer on Earth, the star appears to pulse with each rotation, hence the name pulsar. It's also worth noting the role of neutron stars play in the grand scheme of cosmos. They are crucial in creation of heavy elements. When the neutron stars collide in the spectacular explosion known as kilonova, they spew out spray of atomic particles. Now these particles then combine to form elements heavier than iron, including gold and platinum. The gold in your jewelry, yeah, it just might be the remnant of neutron star collision from billion years ago. Now these peculiarities make neutron stars one of the most fascinating objects in the cosmos. Their intense gravity, powerful magnetism and rapid rotation and role in the element creation are all contribute to their intrigue. As we continue to explore and understand these cosmic anomalies, who knows what other secrets we might uncover. So let's keep our telescopes trained and our minds open as the adventure into the enigmatic world of neutron stars continues. Among many extraordinary phenomena associated with neutron stars, one stands out: kilonova. Now this celestial event is as magnificent as it is crucial to our understanding of the universe. So what is kilonova? A kilonova is a transient astronomical event that occurs in a binary star system when two neutron stars or a neutron star and a black hole collide. Now this collision causes powerful explosion, releasing enormous amount of energy, but the real magic happens in the aftermath of the explosion, when the conditions become ripe for the creation of heavy elements. You see, during kilonova, the intense heat and pressure causes neutron-rich material of the stars to undergo rapid neutron capture, a process known as R process. This process gives birth to heavy elements including some of the most precious substances on Earth like gold, platinum and even uranium. In fact, nearly half of all the elements heavier than iron in the universe are believed to be created in kilonovas. It's fascinating to think that gold in your jewelry or uranium-powered nuclear reactors may have originated from the wreckage of colliding neutron stars billions of years ago. But what's more, kilonovas also serve as cosmic lighthouse. Their bright afterglow reveal the location of these powerful collisions, and this in turn allows astronomers to study these events and gain deeper insights into the nature of neutron stars and physics of extreme matters. In essence, kilonovas are not just spectacular cosmic fireworks, they also play a key role to understanding how the universe works, how elements are created, and how neutron stars interact. Kilonovas therefore provide us with glimpse into the cosmic forge where elements are created. So what's the future of neutron stars? With time, even neutron stars face a fate. In the cosmic ballet of celestial bodies, neutron stars have a unique dance. After their dramatic birth, in the explosion of a death of a massive star, these compact dense object begins a long journey of cooling and transformation. Like a pot of tea left to steep, neutron stars cool over time. This process, however, is not measured in minutes or even in years, but in millions, even billions of years. As they cool, these once brightly objects become cold remnants. Their once fusion energy is reduced to mere whisper in the cosmic dark. These neutron stars, despite being cold, remain incredibly dense. Now, this density is so remarkable that it boggles the mind. Imagine, if you will, a teaspoon of neutron star matter. On Earth, this is seemingly insignificant amount. But the journey of neutron star doesn't always end in a quiet, cold remnant. Some of the neutron stars, those with more massive cores, face a more dramatic fate. Their intense gravity, unable to held at bay any longer, causes a star to collapse inward towards itself. Now, this catastrophic event births an object even more mysterious and fascinating: a black hole. Black holes, the final resting place of some of the neutron stars, are points in space where gravity is so strong that nothing, not even light, can escape. They are the ultimate expression of density and gravity that characterizes the neutron stars. The future neutron star is a tale of cooling, transformation, and in some cases, ultimate collapse. Each neutron star's journey adds a new chapter to our understanding of universe and the laws that govern it. Well, these are but a few facets of intriguing world of neutron stars. To recap, so we have journeyed through the life of neutron star, from the birth to a potential black hole transformation. It's been quite a trip, hasn't it? We have delved into the unbelievable density of these celestial bodies, where single teaspoon of neutron star material would weigh as much as a mountain on Earth, a testament to the extreme environment that exists beyond our home planet. We have explored the discovery of neutron stars, those intriguing remnants of massive stars that have exploded as supernova. These stars, composed of super dense neutron rich, continue to captivate scientists and stargazers alike with their intense gravitation and magnetic fields. So, if this journey through the life of neutron star has piqued your interest, I encourage you to delve deeper. The universe is a vast and fascinating place, full of mysteries waiting to be unraveled. Remember, a universe of wonder awaits you. Don't forget to like, share and subscribe to our channel, and I'll see you next time around. Bye bye.